Hello friends, myself Dr. Nandakumar Raubawale from College of Engineering Ambazogai is going to deal with fluid mechanics. So in previous lecture we have discussed about the derivation for work done by a centrifugal pump, manometric head and efficiencies of centrifugal pump. So today we are going to discuss few numericals on centrifugal pump. Let us see very first numerical. So internal and external diameter of centrifugal pump are 200 mm and 400 mm. So internal diameter, that is D1, is 200 mm and external diameter is D2 is 400 mm respectively, that is 0.2 meter and 0.4 meter respectively. The pump is running at 1200 rpm, that is nothing but 1200 rpm is N revolutions per minute. So the pump is running at 1200 rpm, where the vane angle of impeller at inlet and outlet are, so vane angle at inlet theta is 20 degree and vane angle at outlet is phi, and that is 30 degree respectively. The water enters the impeller radially. Water enters the impeller radially, that means, so this angle alpha is equal to 90 degree. So this term, water enters radially into the impeller, gives the angle alpha which is equal to 90 degree, and the velocity of flow is constant. Velocity of flow means Vf1 is equal to Vf2. Constant means at inlet, the velocity of flow at inlet is equal to velocity of flow at outlet. So that is constant, and he is asking us to determine the work done by the impeller per unit weight of water. So per unit weight of water, so weight W we have to assume as 1 Newton per second. So we will collect this data. So plan of solution. So internal diameter is 200 mm, that is nothing but 0.2 meter, and external diameter is 400 mm, means 0.4 meter. Impeller is running at 1200 rpm. So the angle, vane angle at inlet is theta 20 degree, vane angle at outlet is 30 degree. So this angle theta, vane angle at inlet is theta, that is 20 degree, vane angle at outlet is phi, and that is 30 degree, and angle alpha, so this angle is alpha which is 90 degree, and Vf1, Vf2, that is velocity of flow at inlet is equal to velocity of flow at outlet. So he is asking us to determine work done, that is in Newton meter per Newton, so per unit weight. He is asking it as per unit weight. Therefore, so the formula for work done per unit weight is given by 1 by g. If it is asked in per second, then this numerator in place of 1 there will be w. So now 1 divided by g, vw2 into vu2. So vw2 is velocity of wheel at outlet, and u2 is velocity tangential velocity at outlet. So what we know, we have to find out this vw2 and u2. So g is constant. So to find out vw2 is involved in this tan phi. So tan phi means, you can see here this triangle, say for example triangle A B C. So in this triangle A B C, opposite side is AC divided by base is BC. AC means Vf2, velocity of flow, and BC means U2 minus VW2, U2 minus VW2. So what we know, Vf2 is not known, U2 is not known, VW2 is also not known, phi is only known. So phi is for 30 degree. Now what he is saying is that Vf1 is equal to Vf2. This is the hint given to us. So now this Vf2 is there in this tan theta. So if we consider angle PQR, tan theta, so opposite side is PR divided by base is QR. PR is nothing but VF1 and QR is U1. So theta is known to us. Again here we don't know VF1 and U1. So but we can find out U1 using this formula, that is U1 is equal to pi D1 N divided by 60. We know D1, we know N, we can find out U1. So once we find U1, we can substitute here. Theta is known, VF1 we can get. So once we know VF1, VF1 is equal to VF2, we can substitute in this equation. So tan phi. So here we can get the value of VW2. So U2 is unknown, U2 can be obtained by this. So very first where to start is, first we find out U1, then we find out U2, then we will find out VF1, then we will find out VW2, and then work done. So we'll start from bottom to top. So now very first we have to find out U1 and U2. So let us see velocity, tangential velocity U1 at inlet and outlet, that is U1 is equal to pi D1 N divided by 60. So pi D1, the value of D1 is 200 mm is 0.2 meter, 0.2 into revolution, RPM is 1200 divided by 60. So on simplification, this U1 value we get as 12.56 meters per second. So this is U1. Now U2 is equal to pi D2N divided by 60. So pi into D2, diameter at outlet is 400 mm is 0.4 meter. This is 0.4 and RPM is 1200 divided by 60. So we get U2 velocity, tangential velocity at outlet is 25.13 meters per second. Now next what we have to find out is, once we know U1, U2, then we will use this formula tan theta. So tan theta is equal to VF1 divided by E1, VF1 divided by E1. So what we can find out here is VF1 is equal to U1 tan theta. So VF1 is equal to U1 tan theta. So E1 we know that is 12.56. Tan theta value is given in this problem is 20 dB. So we get from this as VF1 value is equal to 4.57 meters per second. This is velocity of flow. VF1 is equal to 4.57. So in problem itself one thing is given, that is VF1 is equal to VF2. So therefore we can write VF1 is equal to VF2 is equal to 4.57 meters per second. Now once we know VF1, VF2, so we can find out VW2 using this formula tan phi. So we know VF2, we know U2, we know phi. VW2 is unknown, so directly we can find out VW2. So we'll use tan phi is equal to VF2 divided by U2 minus VW2. So VF2, sorry, we can take this as u2 minus vw2 is equal to vf2 divided by tan phi. So what we can do is u2 minus vw2, which is in denominator, is transferred on left hand side. So and tan phi, which is on left hand side, is transferred on right hand side in the denominator. So here we want to find out vw2. So vw2 minus vw2 is equal to vf2 divided by tan phi minus u2, or vw2 is equal to u2 minus vf2 divided by tan phi, or value of u2 is known, that is 25.13. so we can take this 25.13 minus of vf2. vf2 is 4.57, which is known here. vf1 is equal to vf2, 4.57 divided by tan phi value is given in this problem, that is 30 degree. So on simplification we get this as vw2 is equal to 17.215 meters per second. So this is velocity. Now we are left with the work done. So we know vw2 also. Now you know vw2, u2, g, work done per unit weight we can find out. So work done per unit weight that is equal to 1 divided by g, vw2 u2, 1 divided by 9.81 into vw2, 17.215 into u2 is 25.13. So this gives us work done as 44.1 Newton meter per Newton. This is the work done which is asked in this question. So this is how we are going to get the work done. Now we will simplify next problem. So this is the second problem, where a centrifugal pump having outer diameter 2 times, so d2 is 2 times d1, or we can call as d1 is equal to d2 divided by 2. So 2 times inner diameter. So inner diameter is smaller, so outer diameter is larger. So outer diameter is equal to 2 times inner diameter, and running at 1000 rpm. So speed is given, n is equal to 1000 rpm, works against total head of 40 meters. So manometric head hm is 40 meter. The velocity of flow through impeller is constant. Again, velocity of flow is constant, means vf1 is equal to vf2 and that is equal to 2.5 meters per second. Vanes are set back at an angle of 40 degree at outlet. So vane angle at outlet is phi, and that phi is given as 40 degree at outlet. If the outer diameter of impeller is 500 mm, so outer diameter is 500 mm, is this is d2 is 500 mm, and width at the outlet is 50 mm, that is b2. Width is given by b2, which is 50 mm. Determine vane angle at inlet. So we have to find out theta. Then work done by impeller on water per second. So here work done per second is asked. So in previous case work done per unit weight. Now again, third point, he is asking us to find out manometric efficiency. So now we'll collect this data. So pump is running at 1000 rpm and manometric head is given as 40 meter. So velocity of flow is constant, that is 2.5 meters per second. So vane angle at outlet is 40 degree and diameter at the outlet or external diameter is 500 mm. So one condition is given that the internal diameter external diameter is twice the internal diameter. So d1 is equal to d2 divided by 2. So inner diameter is half of the outer diameter and width is 50 mm. So he is asking us to find out vane angle at inlet, work done per second and manometric efficiency. So now to find out theta, tan theta is equal to vf1 divided by e1. This formula we can use. So tan theta, so if we see this angle PQR, opposite side is PR divided by base is QR. PR means VF, so velocity of flow, and QR means U1. So from this what we can find out is theta we have to find out. So which we want to find out, VF1 we don't know, VF1 we know, that is given in this problem, that is 2.5 meters per second, and U1 we can find by using this formula, that is pi d1n divided by 60. So d1 is not given, but directly it is not given. d1 is equal to d2 divided by 2. We can find out d1 also. So we will get u1. So once we get u1, we know vf1, so we can find out theta. So once we get theta, then we go for work done per second. So work done per second is given by weight divided by acceleration due to gravity, vw to u2, velocity of wheel at outlet, velocity of tangential velocity at outlet. So this tangential velocity at outlet can be obtained by pi d2n divided by 60. So we know d2, we know n, we can obtain u2. So now to find out vw2, we can use tan phi is equal to vf2 divided by u2 minus vw2. vf2 we know and phi is also known. u2 can be already, u2 is obtained, u2 we substitute, and from that vw2 can be obtained. So now vf1 is equal to vf2 and that is given. Okay, then what is unknown here is w. vw2 we get here. Then w can be obtained, weight of liquid is rho g into q. Mass density and acceleration due to gravity is weight density into discharge. So this discharge q is given by pi d2 b2 into vf2. So pi is constant, d2 is known, b2 is given, vf2 is given, so q can be obtained. So after getting this q, we can get w, and then we can get vw2 and u2, we can get work done. So after that, he is asking us to find out manometric efficiency. Manometric efficiency formula for manometric efficiency is G into HM divided by VW2 into U2. So HM is given, G is constant, VW2 is already calculated, U2 is also already calculated. So now we'll proceed in the reverse way. So first of all, we take this first part. So first part, this is second part, and third part. Three things are asked. So first we find out u1 and u2. So tangential velocity at inlet is equal to pi d1en divided by 60. So pi diameter d1 is again 500 divided by 2 means 250 mm. So 250 mm. So 0.25, and rpm speed is given as 1000 divided by 60. So tangential velocity at inlet 13.09 meters per second. So now we find out u2 is equal to pi d2n divided by 60. So pi into d2 is 500 means 0.5 meter into 1000 divided by 60. So this gives us 26.18 meters per second. So this is u2, this is u1. So now if we see here, u1 is known, vf1 is known, tan theta. So theta value we can obtain. Tan theta is equal to vf1 divided by u1. So theta is equal to tan inverse vf1 divided by u1. Tan inverse vf1 is given here in this problem as 2.5. u1 is given as 13.09. So theta we get here as 10.81 degree. So theta is known to us. Now coming to this next word. So u2 already we have obtained. vf2 we know. So phi is known. vw2 we can obtain. So tan phi is equal to vf2 divided by u2 minus vw2. So u2 minus vw2 is equal to vf2 divided by tan phi, or vw2 is equal to u2 minus vf2 divided by tan phi. We can simplify this. So u2 we know, u2 is 26.18 minus vf2 is 2.5. Tan phi value is 40 degree. So vw2 is, we are getting as 23.2 meters per second. So we know vw2 now, we know u2, so we must know w, weight is equal to rho gq. So first we'll find out q, then we will find out weight, and then we will find out work done. So now we have to find out q. Discharge q is equal to pi d2b2 into vf2. So pi value is constant, diameter at outlet is 0.5 meter, into b2 is 0.05, that is 50 mm, into vf2 is 2.5. we can see here d2 is 500 means 0.5 meter, b2 is 50 mm means 0.05 meter, this is 0.5 meter, and vf2 which is given in this problem is 2.5 meters per second. So on simplification we get this as 0.1963 meter cube per second. This is Q. Now W is equal to rho into G into Q. So rho is 1000 into 9.81 into Q is 0.1963. So now already this W is known. So now work done is equal to W divided by G into VW2 U2. W is again 1000 into 9.81 into 0.1963 divided by 9.81. VW2 value which we have obtained here is 23.2 meters per second, and U2 value we obtained is 26.18 meters per second. So we get here work done as 119,227.9 Newton meter per second, or this is in watt, so 119 or watt. So if we divide it by 1000, it will be 119.2279 kilowatt. So this is the work done in Newton meter per second he is asking, so therefore we are getting this answer. Now very last thing that is asked here is manometric efficiency. So the formula for manometric efficiency, third bit, manometric efficiency is equal to G into HM divided by VW2 into U2. So G is 9.81 into HM, manometric head which is given in this problem is 40 meter divided by VW2. VW2 is 23.2 meters per second into U2. U2 is 26.18 meters per second. So on simplification we get this as 0.646, or in percentage it is 64.6%. So manometric efficiency is 64.6%. So answers are theta, vane angle at inlet is 10.18 degree, degree. Then work done per second is 119,227.9 Newton meter per second. Then manometric efficiency is 64.6%. So these are the answers for this problem. So we stop here, and in next class we will see the things which are remaining.